What's good, everyone, and welcome back to another video. Today we're going to be doing another LeetCode. If you see my previous video, I've worked on the binary tree in order traversal for DFS. So with this one, it's going to be binary tree pre-order traversal. If you see my previous video, it is very similar. All I'm changing is the order of it, of the recursion. So I would recommend watching the previous one. But again, I'll be doing the same thing. It would just be much shorter. And then and since it's a short video, I might go ahead and just post a second video for post order. So, once again, I'll still read the prompt, write out the code, read and then explain it, show time and space complexity, blah, blah, blah. But it would be a lot shorter, I believe. So what we have here is 144 binary tree pre-order traversal. Given the root of a binary tree, return the pre-order traversal of its node's value. So for in order, it was left to node to right. So for pre-order, it will, instead of left node right, it'll be node left and then right. So all we have to do is just know that for every node n, pre-order traversal it's going to first visit the node itself first, and then traverse to the left subtree. And once it's done with the left, it's going to backtrack and then traverse the right subtree. So I'll be writing out the code. Here we go. Okay, so, and also, again, they already defined the binary tree node. So yeah. So I'm going to import Java, and I want to import array list. Afterward, I want to import Java again, and I just want to import list. Down here, I want to do list with integer. We're going to have a result. We're going to call it result new array list. Boom, boom, boom. Afterward, I want to go down here and create a helper function. And because it's pre-order this time, I'm going to call it pre-order helper. And down here, what we're going to have is the tree node. We're going to call it node, and list, integer. We're going to have a result. Inside, we're going to first write the base case, which is if node is equal to null, then just return. Afterward, all we have to do is, I'll write down the comment first. I'm going to visit current node. Afterward, we want to traverse left subtree, and then lastly traverse right subtree. So to visit current node, all we have to do is result.add, and we're going to add in the node value, so node.val. That's it. For traverse, we want to call in the pre-order helper, and then just put node.left, because left for left subtree, and result. And again, pre-order helper is going to call itself node.right, and then we're going to have result as well. And that is it for that part. Now here, I'm going to be writing pre-order. We want to call it, obviously. So pre-order helper, and we're going to put in the root, because the root's right here. We want to put it in, whatever's the root. And then finally, result. And you want to return the result. So just making sure, if you don't want to watch the previous video, that is fine. I'll still explain it. So what we have here is this part, the function LeetCode calls. We have the result. Result will store all nodes value in the pre-order. So right now it is empty, and then we're gonna call the helper to starting from the root. So we have the pre-order helper, and we call this from the root. And then finally, once we're done with everything, it's going to return the result. Now, what we have here is this is for the node is the current node that we're at. If it's null, if the node is equal to null, that means we have an empty subtree, right? And if that's the case, just return it. Now, what we do here is for the pre-order, remember, like I mentioned, you want to do node first. So, right, that's why I added result.add, because we want to immediately add the node value to the list. Once we're done with that, then we do the recursion for the pre-order, right, which is for the left child. So we're going to do that by calling itself for the node left. and then afterward you want to call, once it's done, you want to call itself for the right. So recursively do preorder on the right child. So the order of these 3 lines is the traversal order, so it's node left right. Now let's do a quick simple run. All right, case is complete, and then I'm gonna submit it. Perfect. There you go. All right, now I'm gonna pretty much provide like the example with example 1. So we're gonna have the I forgot, sorry. So we're gonna call so first of all, remember result is empty or equals empty. And then we're gonna call in the preorder helper for 1 in result, by the way. So when it calls the preorder 1, that means node is currently 1. And once that happens, and since node is not null, we want to add in the result, right? So we're going to add the 1 in. Now it's going to call the left. So 1 dot left, because it's no dot left, so 1 dot left. When you look at 1 dot left right here, it's pointing at null. So if that's the case, that means if node is equal to null, we just return it. So returning it is kind of just like skipping it. So now we do 1 dot right, which has a preorder of 2 right here. So when that happens, that means node now equals to 2. Oh, by the way, don't forget, we got to add the 1 in because you already did it. So now once node is 2, we want to do this again. So we add the 2 into the result. And then now it's going to do the, I'm just going to remove this part. Now it's going to do the left side, checking if there's anything for the left. There is, which is preorder helper for 3. So that means now node is 3. So when it's 3, we go and add the result in. So it's going to add 3. Now we check the left side for 3. There is nothing, so it's null, so you skip it. You check the right side for 3. It is also null, so you skip it. Now, once you're done with 3, you go back to 2, because don't forget, you only did the 2 for the left part. You haven't done the 2 for the right. So you do the 2 for the right, 2 is pointing at null, so you skip it. And then you backtrack back to 1 completed, 2 completed everything, 3 completed everything, and 1 completed everything. So when that happens, then you're done. Then it returns the result, which will be 1, 2, and 3. And that's it. Very simple, very quick. Nothing really much to say about. So now we're going to talk about quickly on the time and space complexity. So I want to do this first actually. We're going to let n be the number of nodes right here. So that means for time, it will be big O of n. The reason for that is because we visit each node exactly once. Okay? And then for the space, the list, we have to add everything to the list. So it will also be big O of n. So recursion call, it's just because you have to add like the output, you're going to have to add everything in, right? So you got to have the space for it. So big O of n for time and space. And that is it. Thanks for watching.